And up next is Hao Lee from Pinscreen. Welcome, Hao.
Hi, everyone. Thanks for being here. My name is Hao Lee. I'm the CEO of Pinscreen and also an associate professor at USC, as well as the director of the USC Institute for Creative Technologies. Okay, so what I do is I build technologies that makes the creation of virtual avatars accessible to everyone. And the reason why we build this is that we believe that at some point, and someday, we're going to interact with photorealistic digital avatars. So you can imagine, the type of impact that we can have. So just to name a few applications, can be useful, obviously, for e-commerce. Imagine you'll be purchasing things directly from Jeff Bezos himself. But one thing that is a big application for us is in the fashion space, right? So the idea is basically to solve the virtual fitting room problem. If you have the ability to create a digital version of yourself very easily, you can have the ability to preview how you would look like in different clothings, customize, and have a much more personalized experience, right? And obviously, this type of branding of fashion, it's already happening, especially with virtual characters and virtual influencers, right? People that don't even exist. And another problem that we're trying to solve using the creation of 3D avatars is in telepresence, right? So both in VR as well as in AR, if you want to have the ability to connect with each other remotely, then obviously you need to have the ability to generate a 3D avatar very easily, right? So now the problem is, how do we create digital humans? So we've seen a lot of amazing technologies today, but one issue is common with all of them, right? So first of all, you can use the traditional VFX pipeline in order to create a digital human. Obviously, very, very expensive and very, very difficult to generate a photorealistic digital face. But we've also seen that it's possible to render these 3D avatars in real time, right? So you have end-to-end solutions that can play back, capture the performance of an actor, and directly render it inside a game engine. The only problem here is that it still takes months, hundreds of thousands of dollars, just to create the digital assets. And that's one of the problems that we're trying to fix, which is we're trying to build an AI pipeline that automatically generates these characters. And as pointed out today multiple times, there's also this uncanny valley problem. So we're also trying to solve that problem. So how do we digitize faces typically, right? So first of all, the typical pipeline to get the best possible capture out of someone, you would go inside our labs, you would capture your face using something called, for example, LightStage, so it's a multi-view stereo capture system, using controlled lighting, so you can capture all the details of your face. The only problem is that no one can really afford the system, this $1 million system at home. So what we've done is we've tried to train a deep neural network to basically generate the same type of content using this type of capture device, right? So here's an example of our recent work that we've published at SIGGRAPH last year. So on the left, you can see a regular iPhone picture, simple selfie, and the algorithm can actually generate a realistic scan of the person, as well as specular maps, high-frequency details of the person just by looking at this single input image. Now, this is nice, but the problem is that most of the images that are taken in the wild, and if you really want to make these type of things accessible to anyone, they are all taken in unconstrained situations. So imagine that any picture you download from the internet, someone is smiling, someone's doing a duck face, and the lighting conditions might not be ideal. So what do we do then? We've recently developed an algorithm called deep face normalization. So the idea here is that any picture that you take, it can basically generate a passport type picture out of it, right? So these are multiple intermediate steps. So you have one input image with really bright lighting condition, a facial expression of the person, and we're trying to normalize the face. So in this sense, we can basically generate an ideal identity of that person, and even not for the application of digital avatars, we can even use it in law enforcement. So this is a kid that has been kidnapped. The only picture that was available is a smiling face, right? So we can neutralize the face and predict how that kid would look like if it was doing a neutral face. So back to avatars. The best way to actually try our technology is to download our app from the App Store. So it's called Pinscreen. And what it does is that you take a picture, you upload a picture, and it generates a realistic 3D avatar of your face, the hair, and also builds an entire body, right? So simply go to the App Store. And to give you an idea on what our company actually does, we're actually doing partnerships with a couple of major retail companies in Japan. And this is an example where we're basically building the next generation fashion catalog. So you're not going to see models in it, but yourself in it. And it doesn't stop with just static 3D avatars. We're also looking at how do we create expressive and realistic facial animations. So probably everyone in this room knows that all you need is regular video camera. You can track your facial performances in real time. But it's not that's not it, right? So what we're trying to do is to use deep neural networks to actually generate photorealistic faces. So here's an example. On the upper right, you can basically see a single input image, and on the lower right, you can actually see facial expressions of that person that is being generated in real time. Now you can imagine the type of implications that you can do. So we can do this real-time face swapping demonstration, download a picture of Kim Jong-un, and you can perform in real time in front of the RGB camera and be that person, right? So this thing has been recently demonstrated at the US Congress on the first hearing on deepfakes, right? So there were some demos that we were showing to raise awareness, and here's another demo that I'd like to show. This is in collaboration with the Washington Post. So what we did was only focusing on the mouth. We're trying to synthesize, put new things into the mouth of the anchor.
But seeing isn't always believing anymore. For instance, how do you know that I'm the one who's talking to you right now? Glenn didn't just say that, I did. False and misleading videos are circulated online, spread by politicians, advocacy groups, and others, and they're often viewed millions of times.
All right, so to conclude my talk, we're going to push a lot in the direction of AI-driven graphics. Imagine a world where we're no longer just looking for information on YouTube, but it's generating the content for you. If you have the ability to basically use AI to generate any content that you want, you have the ability to have a new form of personalized experience. And if you can convincingly simulate things in virtual reality, possibly we can get back into the physical world, and hopefully someday we'll get deeper connections to virtual beings. Thank you.
Thank you, Hao.